get a book and a pen. So we are starting, but these are the
Recording in progress.
Class. We have Ida, Sonia, Areli Ring, Igeme, Waigeme Ryan, Leila, Benicia, Annabelle Namatome, Owomugisha Vanessa, Audrey, Winnie, Orie, as others they find us in the class. Just we are going to remind ourselves something small for about yesterday's work. We are going to remind ourselves something small about yesterday's work. We're looking at the displacement method. We're looking at the displacement method yesterday. And they might say, find, it's just, we are reminding ourselves that you might get a question. You might get a question like this. And the question might be, study the diagram below. Study the diagram below and use it and use it to answer the question and use it to answer the questions that follow. And use it to answer the questions that follow. When you are talking in our class, and use it to answer the questions that follow. And they give you something like this. This is our diagram. This is our diagram. This is the diagram. We have 5 cc and 10 cubic centimeters. Then on the same diagram, we have got this. We have got that. Now we can see that this is K, this is M. And the questions which they might bring here, they might talk about the first question. Question Roman 1. They say, name the containers. Name the containers marked. Name the containers marked. Part A, K. Name the containers marked K, then M. Name the containers marked K, then M. Then they come to Roman 2. They tell you of what importance of what importance is the string of what importance is the string in the above? Of what importance is the string in the above experiment? Of what importance is the string in the above experiment? This is the string. Now, Ryan, read for us the statement. Read for us this statement in the right.
Study the diagram below and use it to answer the questions that follow.
Yes. Now, Ryan, can you read for us the first question? The first question, Roman 1.
Name the containers marked K and M.
Yes, name the containers marked K and M. Just we are reminding ourselves about yesterday's work. Who can tell us the container marked K? Who remembers the name of the container marked with letter K? Who remembers the name of the container marked with letter K? The name of the container marked with letter K? Benisha?
Overflow can.
Overflow can. Thank you. Container marked K is called overflow can. Container marked K is called overflow can. Or we call it Eureka can. Container marked B. Ryan, container marked B.
A measuring cylinder.
A measuring cylinder. Very good. Container marked B is a measuring cylinder. Container marked B is a measuring cylinder. Very good. Yes, Owomugisha Vanessa, read for us question Roman 2. Owomugisha Vanessa.
Of what importance is a string in the above experiment?
Of what importance is the string in the above experiment? Who can tell the answer? Who can tell the class? Who was the answer? I'm seeing very many participants. The hands are up. Alwell ring. Alwell ring. Alwell ring is not ready. Let me see. Someone else. Yes, Audrey, what is the importance of the string in the above experiment?
It helps us to lower the stone in the overflow can gently.
Very good. The use of the string is to lower the stone gently. A string is used to lower the stone gently. A string is used to lower. A string is used to lower. A string is used to lower the stone gently. The stone gently in an overflow can. In an overflow can, or we can say in water. In an overflow can or in a water, because that water is in the container called overflow can. Because when you just throw in a stone, the water will splash and you won't get the exact volume of the stone or the volume of the irregular object. So a string is used to lower the stone gently in water. Why is she saying a stone? Now this is a stone, but we have very many irregular objects. So it's a string is used to lower the stone gently in water, because in the diagram that is a stone. When they ask you what is the volume of the stone, according to what I told you, that the volume of a stone is equal to the volume of water displaced. The volume of a stone is equal to the volume of water displaced. This is water. When you lower a stone in water, so the volume, the stone will displace the volume of water, which is equivalent to its volume. Now, what is the volume of a stone? When they give you an overflow can and they give you a measuring cylinder, we just consider what is in the measuring cylinder. Here, we don't subtract because you have got two containers. So the volume of a stone is 10 cubic centimeters. We just take what is in the measuring cylinder. What is in the measuring cylinder? The liquid, the volume of the liquid, the volume of water which is collected in the measuring cylinder, it is equivalent to the volume of the stone in an overflow can. So the volume of a stone is 10 cubic centimeters. Why do we say so? Because the water which was displaced from the overflow can is into the measuring cylinder is equivalent to 10 cubic centimeters. We don't subtract, but we just take what is collected in the measuring cylinder to be the volume of the irregular objects in an overflow can. Why did the primary 5 pupils choose to use this method when finding the volume of a stone? A stone is an irregular object. But which method is this? I'm forgetting the name of this method. Who remembers which method is shown in the diagram? Which method is shown in the diagram? Which method is shown in the diagram? Yes, Winnie Zizi, Winnie Orie, which method is this? You are quiet. Leila, name the method shown in the diagram. Leila. Omugisha Vanessa, which method is this for finding the volume of regular objects?
Displacement method.
The method is displacement method. Okay, class. For yesterday's work, please we have reminded ourselves something. Today we are going to look at something. Let us also go there. Today we are going to look at something here. Let us go back to it and we look at it. So today we are going to look at this. Today we are going to look on your screen. It is something on your screen. I want Annabelle Namatome. Annabelle, read for us what is on the screen. Annabelle. Annabelle. Shama Brandon. Shama
Yes, teacher.
Brandon. Read
Yes,
for us
teacher.
what is on the screen.
Primary 5 Science, 24 September 2021. Lesson, Weight, Mass, and Density by Teacher Joseph.
Very good. Thank you. It is weight, mass, and density. Today we are looking at weight, mass, and density. We want to know what is weight. 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 Yes, Shama Brandon. Shama Brandon, what is weight?
Weight is force an object
Something small. Weight is there. Weight is the force. Something small, sorry. Weight is the force on, not an. Weight is the force on an object. Weight is the force. Weight is the force of an object that exerts due to gravitational force. Weight is the force of an object. Weight is the force on an object that exerts. Weight is the force on an object that exerts due to gravitation force. Yes, Shama, ready for us? What is weight?
Weight is the force on an object that exerts due to gravitation force.
Yeah, weight is the force on an object that exerts due to gravitational force. Or we can say, if you're writing still, we can say weight is the gravitational force. We can say weight is the gravitational force. You can also add in this one, weight is the gravitational force. Weight is the gravitational. Weight is the gravitational force exerted on an object. Weight is the gravitational force.
Teacher will also write it.
Yes, weight is the gravitational force exerted on an object. That is a simpler English. You can say weight is the gravitational force exerted on an object. Or weight is the force on an object that exerts due to gravitation force. That one, it looks a bit complicated, but when you take the second one also to add on the first one, you can just say weight is the gravitational force exerted on an object. We know that the force of gravity, this is the force that pulls the objects towards the center of the earth. Like when you throw a stone up, the stone comes back to the ground. So the force that pulls the objects which are thrown in air back to the ground is what we call the gravitational force. So if that force is exerted on an object, is what is termed to be the weight of an object. Weight is the gravitational force exerted on an object. Now, there is that statement in red. They are saying that the weight of an object is determined by the following. You know, there are different things, they have different weights. You cannot compare my phone, the weight of my phone, and the weight of a brick. A brick, according to its size, is bigger than my phone, meaning that its weight will be greater. Now, let us look at the factors which determine the weight of an object. You know, different objects, they have different weights. Let us look at the factors that determine the weight of an object. Yes, Sonia, read for us from here, the weight of an object. From the word, the weight of an object in red color, Sonia. Yes, Hannah. Hannah Katsime, read for us.
The weight of an object is determined by the following: size
Yes.
of the object,
The first one is size of the object. Yes. The second one,
material from which an object is made,
yes, the material from which an object is made. The third one,
the pull of the force of gravity,
the pull of the force of gravity. You can end here. Thank you. They are telling us that the weight of an object is determined, one, by the size of an object. The weight is determined by the size of an object. The weight is determined by the size of an object. Meaning, those objects which are heavier, they are bigger. And the objects which are lighter, they are smaller. So if an object is small, it will be light. When the object is big, it will be heavy. Now, another thing, another factor that determines the weight of an object is the material. Another factor that determines the weight of an object is the material from which an object is made. From which an object is made. From which an object is made. Like if an object is made from cotton wool, though it is big, you cannot compare it from an object which is made from iron, from a metal. Like if I make a model of a pot from a metal, or the model of a radio, I make a radio from wool and a radio from metals, you'll find that the metallic radio will be heavier than this woolen radio. So the material from which you're going to make something determines its weight. And another thing they're talking about, the pull of the force of gravity. Now therefore I'm going to ask you, teacher, what are you talking about? What do you mean about the pull of the force of gravity? You have ever seen the moon at night? You know, this force of gravity is determined by the height above the sea level, the height from the ground. When objects are nearer the ground level, the nearer the surface, the Earth's surface, you will find that those objects, they will weigh more than the objects which are miles away from the Earth's surface. So the nearer you are to the ground is the more heavy you become. The far miles you are from the ground is the less heavy you are. You become lighter as you're far miles away from the ground. So your distance to the ground level, to the surface of the earth, determines your weight. For example, if Ryan is 30 kilograms now on the earth, if Ryan is 30 kilograms on the earth, if the same Ryan, I'm making a mistake in the name of Ryan. If Ryan is 30 kilograms on earth, if Ryan is 30 kilograms on earth, the same Ryan, if Ryan, this is earth, Ryan is 30 kilograms, but when the same Ryan goes to the moon, when the same person goes to the moon, will be a sixth of the 30 kilograms. Meaning if you are 30 on earth, in the moon you will be 1 out of 6 of 30 kilograms. 6 divided by 6, 1, 30 divided by 6, you will be 5. So Ryan on earth is 30 kilograms, but Ryan, when he's on moon, Ryan will be 5 kilograms. Why? The moon has less force of gravity. The moon has less force of gravity. At the moon, less force of gravity is at the moon. That's why Ryan will be lighter. But on Earth, there is more force of gravity. That's why Ryan will be 30 kilograms on Earth. When we take him on the moon, only 5 kilograms. Why? On Earth, there is more force of gravity, and on moon, there is less force of gravity. Your actual weight will reduce, will be divided 6 times to get 5 kilograms. So you take note. Wherever you go far away from Earth, you will find that our weight will reduce. So they might say, name the best unit for measuring weight. The best unit for measuring weight is called newtons. The best units for measuring weight. For weight, the best unit for weight, it is called newtons. Whatever we get it in newtons. In primary 7, we are going to learn how many newtons are in 1 kilogram, how many kilograms are in 1 kilogram that we want to taught us. Yes, Ryan. Ryan, you have a question?
No.
You don't have a question. Okay. Now, they might ask you, what is mass? 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 Chualianga Fadil, what is mass?
Mass is the
Chualianga,
quality of matter contained in an object.
very
Mass
good.
is constant.
I think you, that's
Mass
enough. That's enough, Chualianga. Mass, when someone asks us what is mass, we say mass is the quantity of matter contained in an object. But remember weight, we said weight is the gravitational force exerted on an object. But mass is the quantity of matter contained in an object. That's what we call mass, the quantity of matter in an object. And here scientifically, they are still telling us, or they are telling us, that mass is constant. Mass doesn't change. Mass is constant. I.e., it means that is to say it doesn't change and it doesn't depend on the pull of gravity. The mass of an object does not depend on the gravitational force. Though it is an object is miles away from the force of gravity, the concentration of the force of gravity is very far from the ground. The mass can't change. Mass is constant, but the weight change. What is mass? Mass is the quantity of matter contained in an object. And mass is constant, that is to say, it doesn't change and it doesn't depend on the pull of gravity. I know for the idea they are forgetting what is gravity. Gravity, this is the force that pulls the objects towards the center of the earth. When you throw a stone up, you tell your friend, your brother, your mother, but mommy, do you know the reason why this stone is coming back on the ground? It is because of the force of gravity. Sometimes when we don't want you to describe the things, we just say, what term describes the quantity of matter contained in an object? What term describes the quantity of matter contained in an object? That term is called mass. Mass is the quantity of matter in an object. Yes. Sonia. Sonia. Sonia,
Yes, teacher.
can you read for us? How do you call the units for mass?
Yes. The units for mass are grams, brackets g, or kilograms, brackets kg. Weight and mass are both measured in the following instruments. Using the following instruments: beam balance and spring balance.
Yeah, the units for mass are called grams. When they say in which units is mass measured is measured in the units called grams or kilograms. Always hear your parents saying, you go to the shop and bring 1 kilogram of sugar. That is mass of sugar in kg or in grams. Weight and mass are both measured using the following instruments. If you want to know the weight or the mass of an object, you are supposed to use the instruments below. One of the instruments is that one. That one is called a spring balance. A spring balance, but they are modified, they have digits. If it is 5 kg, they will show you here there is where you see springs, there is a screen which shows the weight of an object, of the mass of an object. We can use the spring balance, it looks like that, or we can use the beam balance. That is a beam balance, is also used to determine the mass of an object. If you want to determine the mass of an object, you can use a beam balance. The weight, you can use a spring balance. Those instruments are used to determine the mass. Whenever you see an instrument like that one, you just know those people, their calculations, their interest is to find the mass of an object. Whenever you see that diagram, they draw for you in examination, that is a beam balance. To know how it works, you must study hard and you go to secondary. The teachers in secondary, they are going to teach you very well how it works, and you become stars, you become engineers, you become businessmen, you work in companies, but that is the beam balance. There is a set of scales, a scale balance. Now, this is a weighing scale. These days, our parents, when they are buying, that is also for finding the mass. Our parents, when they are buying things in the supermarkets, that is what they use. They go to the supermarkets, they sell to them things, and they first weigh them. That's Irish potato. I know everyone enjoys it. That's Irish potato. So class, for the interest of time, I'll send these notes, and tomorrow we shall start from where we have ended. We shall go through this work again before we look at the next work. Allow me, everyone turn on your video, the likes of the class has got these friends of mine, Hannah, Omgisha, Shama, Audrey, Ida, at whom Jason, Justin, Daniel, Onen, Aluel, Ring, Win, Ori, Annabelle, Ryan, Nanja, Hidayah. Bye. We sign out until tomorrow. Let us sign out. Bye.
Bye, Jimmy. Bye.
Bye.
Everyone.
Bye,
Bye.
everyone.